Hello info person, this is Anton, and in this video we're going to be discussing some of the new discoveries in regards to the least known region in the galaxy, or basically the biggest blind spot in modern astronomy that we usually refer to as the Zone of Avoidance. But to be more exact, we're going to be discussing this new study that as always you can find in the description below, that's finally helping us fill this gap and helping us actually map the local universe, in the process discovering one of the largest structures in the universe, the hidden Vela supercluster. And so let's talk about these topics in a bit more detail, but first let's start by defining what the problem is. So why exactly is it called Zone of Avoidance? And why is it so difficult to see through it? Well, here imagine for a second that you're standing in the middle of the room, possibly in your own house, but it's actually filled with fog. And though you can see the floor pretty well and possibly the ceiling, and can maybe make out your TV and a few other things in your house, as you look further out, everything becomes practically invisible. In this case, the gloom gets much thicker and the view of faraway objects fades away. And so because of this fog, pretty much everything beyond a certain point becomes invisible. And for all you know, there is some kind of a massive object in the back of your house that you're just unable to see, which is actually kind of what we're dealing with here. The problem astronomers are facing is that our galaxy contains a lot of dust and a lot of gas. And so when we're trying to map the universe from inside the Milky Way, because we're inside the flat disk of the galaxy, our view is first of all blocked by billions and billions of stars, and it's also blocked by huge amounts of dust and gas resulting from billions of years of different supernovae. And so these thick clouds and this interstellar dust create certain regions in the night skies that are practically impossible to see through. And the most famous such region is technically here. So right in the middle of the galaxy, the concentration of gas and dust is so thick that it creates this very opaque region referred to as the Zone of Avoidance. And for an extremely long time, this was the region where astronomers basically could see nothing. And this actually represents approximately 20 to even 25% of the extragalactic sky, making this a relatively large region. And so here, the central regions of the galaxy, and also the galactic disk itself, contain so much interstellar dust, mostly made out of tiny rocks and tiny materials made out of soot, that most light gets blocked by all of this, with practically no optical light getting through. And that means that for astronomical observations, using standard optical telescopes here is kind of useless. These grains are just incredibly effective at blocking visible light. But historically, this actually used to be known as the Zone of Few Nebula. And that's because until the 1920s, or basically 100 years ago, astronomers actually thought that we live in a single galaxy, with a lot of these unusual objects that were somewhat spiral in shape, basically being strange nebula. And it just so happens that in this region, for some reason, these nebula were absent. And that's because until 1920s, and until the so-called Great Debate that you can learn more about in one of the videos in the description, astronomers had no idea the universe was actually that big. But eventually they realized that these nebula are not nebula but are enormous distant galaxies. And the reason we're not seeing any nebulae here is because a lot of these galaxies are simply positioned behind the enormous disk of the Milky Way, which of course implies that behind this region there is an enormous amount of galaxies and galactic structures that we've actually never seen before up until relatively recently. And as we've learned in the last decade or so, there are a lot of massive structures hidden back there, including some that are technically mysterious. And the most mysterious of them all is referred to as the Great Attractor. It's this bizarre point somewhere in deep space that many galaxies around us, including the Milky Way, seem to be attracted to and are slowly moving toward. You can learn about this concept in a video in the description, but in a nutshell, it's a sort of an unusual point of gravitational attraction, but exactly what seems to be there, nobody knows right now. But for astronomy this is also important because once again, this represents 25% of the local volume that we just cannot study and cannot see. And this technically can lead to major errors in understanding how the universe seems to work. And so this is definitely a major blind spot. But as we've learned over the years, there is a way to see through this, and there are at least a few tricks. And that's because while dust blocks visible light, it's a lot less effective at stopping longer wavelengths, and specifically infrared and radio waves. And radio waves in particular seem to be the key. And so here, a lot of studies using radio telescopes usually focus on the emissions from the neutral hydrogen. This is the so-called hydrogen line, or the 21 centimeter line, which is formed by the most abundant element in the universe and technically allows us to map a lot of things around us. And the thing is, this radio signal can easily travel through most of these dust clouds, allowing these radio telescopes to directly see everything behind this region and to detect galaxies hiding inside the zone of avoidance. And so most of the recent research from the zone of avoidance has mostly focused on observations from radio telescopes. And though there have been some minor discoveries in the last few years, some of which we've discussed in videos in the description, we now have a major discovery that was just made in early 2026. Although here we're also going to briefly discuss a similar discovery from 2024, because both of these studies examined the same region. And so for these recent studies, researchers used a kind of a hybrid model of observations, which allowed them to directly map the southern zone of avoidance in unprecedented detail. And this was done by combining existing data on how galaxies move from another survey that contained peculiar velocities, or basically velocities based on the redshift measurements, and the observations from the Meerkat telescope in South Africa. And Meerkat is known to be an extremely sensitive array that's exceptionally good at receiving signals through these opaque dust clouds and at basically mapping the zone of avoidance. And the main discovery here was a hidden giant referred to as the Vela supercluster. In this case, researchers nicknamed this Vela Bunzi. The name comes from one of the South African languages, the Xhosa language, and means revealing widely. And though technically the supercluster was actually discovered back in 2016, it was the recent mapping in 2026 that confirmed its enormous size and its official distance to us, approximately 800 million light years away from us. And so I guess the question is, so what is this supercluster and what do we know about it so far? Well, first of all, based on this image, you can actually see that there are quite a few of these superclusters around us. And the one that you see here, Laniakea, that's actually where you live. And Laniakea by itself is also a relatively recent discovery, and we've discussed this not so long ago in the video in the description. And though not the largest supercluster, Vela is still quite enormous. It's estimated to be approximately 33.8 quadrillion solar masses, and seems to stretch across 300 million light years. And surprisingly, none of it seems to be visible to us, and seems to be directly hidden by the zone of avoidance. It also seems to contain 20 individual galactic clusters, and despite not being the largest by size, it seems to be just as massive as Shapley supercluster, making this one of the most massive structures known to us. It also surprisingly seems to have this unusual double core morphology, or basically it seems to contain these two massive central concentrations of matter, resembling a kind of an hourglass. And to make this even stranger, both of these shapes are approaching each other and are slowly moving toward the center, towards some kind of a gravitational point. But because this is so massive, it also of course influences our own galaxy. And so in this case, the Milky Way and the entire local group are technically moving toward this as well, although not as fast as toward the mysterious Great Attractor. And so right now this is officially considered to be the second largest and most massive structure after the Shapley supercluster, and way larger than Laniakea, which is the Milky Way's supercluster. And so yeah, this is an enormous structure that was really only officially confirmed approximately a week ago, making Vela a massive gravitational anchor rivaling a lot of other structures around us. As a matter of fact, according to this study, Vela supercluster might be the primary driver of a lot of different cosmic flows around the Milky Way. In other words, it's one of the main structures we have to analyze in order to understand the mysterious cosmic web that a lot of galaxies seem to be a part of. And here this is important because our galaxy and a lot of the nearby galaxies like the Andromeda are not just sitting still, they're always being pulled by something and are always moving inside this cosmic web. And one of the observational mysteries for the past few decades was actually a kind of an unusual correlation, or a kind of a bulk flow, where a lot of different galaxies seem to be moving toward a lot of specific regions. For example, once again, the Great Attractor. But in this case, the math didn't always add up, and there actually seemed to be just a little bit more pull than we could account for based on a lot of visible matter detected over the years. And so in this case, by finding these massive objects like Vela supercluster, we can potentially explain these anomalies and how these cosmic flows seem to manifest. With the study essentially confirming that both Shapley and Vela seem to be the main players in moving the galaxies in the region, mostly because both of these superclusters are way more massive than anything else in the region. And lastly, this will also help us test a lot of modern physical models such as the Lambda CDM and possibly give us some hints on the mystery of dark matter. As a matter of fact, based on some of these recent observations, the study has already discovered that the bulk flow in this region seems to be at least 3 times faster than what the standard model predicts. And exactly why the galaxies are moving 3 times as fast as they should be moving is currently unknown. But naturally, this technique and this region is still far from being explored. As a matter of fact, there are still a lot of different mysteries hiding here and so many new things to discover. And so, for example, we still have no idea what the Great Attractor is. We also don't really know much about another large structure referred to as the Ophiuchus supercluster that's also hidden by the Zone of Avoidance. And there's the famous local void, or the vast empty region of space right next to us, that also seems to be hidden by the Zone of Avoidance. But in a nutshell, this highlights the importance of radio astronomy for modern science. And so telescopes like Meerkat are transformational for our understanding of everything around us. Here we're basically moving from the time where 25% of everything around us was kind of like those ancient maps where it said, "Here be dragons," to a time when we can now see the actual backbone of the cosmic web, and to even see distant galaxies and how they move. But future telescopes and future observations, especially the survey known as Wallaby, are actually going to provide us with hundreds of thousands of measurements, as opposed to just a few thousand from this particular survey, most likely discovering even more hidden giants and helping us find even more structures. And so even after decades and decades of observations, when it comes to astronomy, we are still in the age of discovery. There is still so much to find. Which means that we'll definitely come back and discuss new discoveries in some of the future videos. Until then, check out some of the videos in the description. Thank you for watching, subscribe, come back tomorrow to learn something else. Support this channel on Patreon where you can find additional videos without any ads, and can DM me directly, or by joining channel membership that grants you early access. You can also support this channel by buying the Wonderful Person t-shirt in the description below. Stay wonderful, I'll see you tomorrow, and as always, bye bye.